Okay, I have started recording. So as a usual practice, I request all the students to drop your roll numbers on the public chat. Is the chat box is visible? Yeah. So let me run through the list of absentees. Absentees as of now, there are 9 absentees, and the absentees roll numbers are 138, 138, and then 151, 152, 153, 154. Okay, 151, 152, 153, and 154, and then 160, 164, 170, and 180. So these are the list of absentees. So meanwhile, if they are joining in between, ask them. I think you are not in a position to see the list of participants. They are anyway already know that they need to drop the attendance. Can somebody respond whether my voice clarity is good and am I audible?
Yes, sir.
Yes, sir.
So before I further proceed, please notice that we have came to the end of syllabus almost. So we typically require some maximum of 2 or 3 hours of lecture slot, by using which we can complete the concepts which are pending as a part of your introductory programming course for problem solving through object oriented programming. Okay. So from here onwards,
Chat box is not opening, sir.
come again. I think somebody is saying something. Yes, anybody?
Chat box I can't open.
Come again.
Chat box is not opening, sir.
Yeah, chat box it will not open. Only in the public chat it is open. You can chat only with me. I think chat box is opening, isn't it? What is your number? Can you once again explain inverse list logic? Work it out. Inverse list logic quite rarely is asked in the exams. 146. Okay, so don't worry about that logic. You start looking the other functions and other aspects. Okay. So somebody was saying some issue. There was a problem in opening the chat. Do you have a problem? Anybody else? Are you having a problem in sending the chat message with a public mode with anybody?
No, sir.
I think chat box is visible, right?
Yes, sir.
Can somebody acknowledge?
Yes, sir.
Okay.
Yes, sir.
Okay, fine. So in today's class, shall we proceed? Any other doubts?
No, sir.
Any other doubts? At least somebody can respond to my question whether I can proceed. Shall I proceed?
Yes, sir. Yes, sir.
Okay. So in today's class, we will focus on implementation of Q class. Okay, so implementation of the Q class by using a single linked list. Okay, so what we will do is in first half of the class, we will understand, we will again revisit some of the fundamental differences between queues and stacks, and in terms of usage point of view, what is the advantage of queue, or how do you justify the usage of queue in any computational system, and what are the differences between stack and queue. So this will be the first half of our discussion, and in the next half we will discuss the strategy that needs to be opted in order to implement a ADT class with a single linked list to be maintained and in order to implement a queue. Okay, so that is today's class agenda, and after that, we will discuss on the modalities in terms of conducting the different assessments. That includes your lab second internal exams, plus your third quiz exam, plus your lab external exam, plus the syllabus for your lab external exam, as well as the other exams, and finally the other aspects, other operational issues such as writing the record and so on. Okay. So is that okay? Am I audible?
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir.
So what is the main reason to study Q? What is or justify any two reasons to study?
Multitasking.
Yeah, so one is the multitasking. So please notice that what is the justification that you have to give? You should not give the vague justifications like issuing the bank token uh, to the customers who are standing in the queue, and then again calling those customers in first out in order to dispatch the money. So these are the examples that you can probably discuss in order to understand what is the meaning of a queue. Or if you consider another example of dispatching the movie tickets, in order to get a ticket, the person has to stand in a queue. Okay, so these are examples which are real world examples, but these are not computational examples. Okay, so whenever you are asked to justify the implementation or need of implementing a queue, okay, so the first need is when we are working on a microprocessor based systems, and when the microprocessor is ported already with the operating system, one of the fundamental aspects of operating system is to provide multitasking. So multitasking is the feasibility of scheduling multiple processes with a single processor. So in order to achieve this, the operating system needs to run some policy based code for every task, and it has to schedule the multiple processes, which in other words they are called as multitasks. So because of this reason we use queue. This is usage number one. Okay, so is the point is clear? Is the first advantage or first need of study why we have to study queue is clear?
Yes, sir.
Can somebody respond? So I think
Yes, sir.
in the last classes I have taken some one or two, I think three tasks. One is, let us say you have a Facebook task, then you have a WhatsApp task, then you have probably a Gmail task. Okay, you are trying to open a attachment which is of 1 MB, so processor cannot be hanged till your entire 1 MB PDF is opened, because processor has to also address the chat messages which are coming on Facebook or on WhatsApp. So processor availability has to be given to all these other processes which are running on top of the operating system. So this facility is done by using a specific code which is again written either in C or in C++. So this is where you predominantly use Q. This is application number one. Clear? Am I clear?
Yes, sir.
Yeah. So the second application is, for example, when you deal with the networking traffic. Okay. So assume that you have a Wi-Fi interface, or assume that you have a Ethernet, a specific network interface. So always network interface is only one interface, one single physical interface, by using which you can either transmit or you can probably receive. So when you do only transmit or when you do only receive, then it is said to be half duplex, because you are doing only one job. On the other hand, for all the networking interfaces, for example, if you take Wi-Fi, so what is the meaning of Wi-Fi? Your device must be in a position to send as well as receive the packets, which is the radio packets. Okay, so when multiple packets are coming in, and when the when the application, whatever you are using, is in a position to access your networking interface in order to send the multiple packets, then there exists a need of policy-based code to access the shared hardware networking interface, by using which both the transmit and the receive processes has to happen. So this is another example of usage of a queue. So let me again repeat. If you have a networking interface wherein it is prone to multiple packets or multiple asynchronous outside data which is coming in, as well as the data which you want to send through the same port, then you have to keep all those things which are coming or which you are sending in a queue. Then only you will be in a position to process. So there exists a need to maintain on specific memory, where that memory needs to be treated as a queue. Okay, so if the data is coming in, then it is nothing but reception. Okay, so you will have a receive queue, and if you are trying to send the data, then it will be a transmit queue. Okay, so this is another example. The simple two examples, let me summarize. First example is to provide multitasking for multiple for offering the multiple processes to run under a single processor based design by the operating system, whereas the second advantage is, our second need is to share a existing single physical network interface, so that the multiple data streams can come in or the multiple data streams can go out with a single interface or with a single port. So these two are the tangible applications that probably you can summarize as the reasons to study queues. Okay, so am I clear? Am I clear?
Sir.
Somebody respond, am I clear?
Sir.
Yes, sir.
Yeah, so now let us look into the implementation of C++ Queue ADT class with the singly linked list. Now again the question is, what is the use of singly linked list? So there are two reasons. The first reason is, if you implement it in the form of an array, okay, if you implement it in the form of an array, then you are demanding continuous memory. Whereas in singly linked list, you can logically connect discrete memory links. That is reason number one. And reason number two, this is where you will appreciate the importance of front node pointer. Okay, so in arrays, implementation wise, if you see, then you require only one offset. You don't even need the front offset. But if you use singly linked list, usage of two offsets, two queue pointers. One is a last node pointer, and second is a front node pointer. Will be very computational speed wise. It will be very efficient. Okay, and unlike arrays where you need to shift all the array elements towards right in singly linked list, that logic is not required. So as a result, you will be saving the computational overhead. Let me again repeat, there are two aspects or two advantages of implementing a C++ queue class with singly linked list compared with arrays. Advantage number one, you are not demanding continuous memory, whereas in the other case you are demanding continuous memory, where in arrays case. Reason number two, whenever you are dequeuing an element in arrays, you need to shift the array, and that is a computational overhead. This computational overhead is eliminated in singly linked list by maintaining two specific pointers, which are front pointer and the rear pointer. Clear? Am I clear?
Yes, sir.
Yes, sir.
Okay. So is the whiteboard is visible?
Yes, sir.
Okay. Good. So now what we will do is, let us discuss about the implementation of queue. So let us assume this is your RAM. Okay, so this is your RAM, right? So here you will have two approaches. Now let me discuss approach 1. First approach is, first of all, you have a node with integer data element, and then you have a singly linked list. Okay, so let us assume that you have kept a first element. Okay, so let us assume the value of that element is let us say 4. The value of this element, the first element is 4, and the pointer to the next node is null. Okay, so initially, so please notice that this path is enqueuing path and this path is dequeuing path. This is enqueue path and this is dequeue path. Okay, so initially we will maintain 2 pointers. Initially we will maintain 2 pointers. So the first one is, let us assume this is let us say rear pointer. Let us say this is the front pointer. So initially front will be pointing to null and rear is also pointing to null. Rear is also pointing to null. Are you following? Are you following?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So the point is, when queue is empty, your constructor code will be very simple, where you need to write rear is equal to null and then front also as null. So this will be the sort of constructor code that you have to write. Is the constructor code is clear? This is the constructor code. Both front point and rear pointers are pointing to null. Also notice that front and rear, they are of what type? Node star type. Okay, so these two are the members of the class. These two, they are the members of the class. Members of Q class.
Sir, they are int star type, no, sir.
They are
Int star type, no, sir.
no. They are node star type. Okay, so inside node you have a single node. Inside node you have int and then pointer to next node. Because we are discussing about maintaining a queue by using SLL, singly linked list. So we will access the data by taking the node. We will access the data by taking the node, and inside node you will have node arrow X. So let me also write, for the benefit of understanding, that you have a type def struct, there is a node. Okay, so you have a self-referential structure with int x, you have node star pointer to next node. So this structure definition is outside of the class. This structure definition is outside of the class. Now inside the class, these two are the members, and this part is the constructor code. Is the constructor code is clear? Now initially Q is null. That means there are no elements, not even 4. Anybody has any doubts? Shall I proceed? Am I audible?
Yes, sir. Yes, sir.
Okay. Now let us assume you are enqueuing. So when you are enqueuing, So here you have two approaches. One is you can assume that the node that you are enqueuing is a friend node and the node that you are dequeuing is a rare node. Or you can also assume that the node that you are enqueuing is at the rare side and the node that you are dequeuing is at the friend side. So among these two notions, using the second one, that means whenever user is inserting a node, the place where user is where the user is inserting, which is nothing but enqueue, I'm going to use rare. Okay. And the place where the user is dequeuing or where the user is taking out, where I need to delete after reading the data. Okay, so that is accessible by using front. So am I clear? Are you with me? Any doubts? Interchangeably, the program will change. So among the two approaches that I have discussed, in enqueuing side, I don't worry about front. Okay, so what I need is access to rare. On the other hand, in dequeuing side, I don't care about rare. What I need is, I need front. Clear? Am I clear?
Yes, sir.
Yes, sir.
Okay. So now let us start about the enqueuing process. So let us assume that you have created a node star type and whose address is, let us say, 100. This is 100. This is first element. Okay. So what am I discussing? I am discussing about enqueuing process. Enqueue what? Enqueue a item. Let us say int k. So during enqueue process, what has to be done? You have to create the memory. So that means you take node star temp initially pointing to null. Is node star temp is equal to null? Is it visible in your screen as well? No. Node star temp is equal to null. Is it visible in your screens? Yes or no?
Yes, sir.
Yes, sir.
Yes.
Visible,
Okay.
sir.
Okay. Now I'm just checking whether this will allow only after completing the instance, then this content is visible. No. So that means the moment when I'm typing, it is visible.
No lag.
Come again.
No lag.
Node. I'm not getting.
No lagging, sir.
Okay. Okay. So there is no delay. There is no latency.
No, sir.
Fine. I just written my name and then erased. Fine. So now assume that in this case, temp is 100. Okay, so in this case, temp is 100. Now the first case is if your friend itself is null, that means this is your first node. Then you have to tell that my friend is temp. Sir, no. Sir, no. In enqueuing process, where you will return upon success end, you are creating a temp node. That means creating means you need to write temp is equal to new node. Now after this, if friend is null, that means already queue is empty. Or no? Then you have to tell that friend is temp. Yes or no?
Yes,
Yes,
sir.
sir.
So after this, you have already initialized in the in the constructor code, saying that both rare and friend, they are all pointing to null. Okay. So now what has to be done? In temp arrow x, which is a newly created node, you are keeping k. So this is where you are keeping 4. Or no? Then the newly
Yes, sir.
created code, the newly created node is the temp, arrow P next, you need to maintain this as null, then only it is a meaningful linked list. And then you say that your rear is pointing to this new node temp. Yes or no?
Yes, sir.
Yes, sir.
Then you say that return 1. So that means as of now I have inserted 4, I have enqueued 4. So let us again revisit the same function or same API. The address of temp is 100. Front is, because it is null, you are saying that front is temp. So front is pointing to 100. Now front is not null now. Here I am changing this to 100. Okay. Now front is pointing to 100, and then in 100 arrow X, I am keeping 4. In 100 arrow P next, I am keeping it as null. So my list is ready. My node is ready, which is the head node. This is the head node. This is the head node, or this is the root node, isn't it? Also, I need to make a control on rear. So whatever the new node that you have attached is itself is the rear node, isn't it? So that means your rear, which was earlier pointed to null, will now point to whom? 100. Both front and rear are pointing to 100 now. Clear?
Yes, sir.
Okay.
Sir.
Now assume that user is willing to enqueue again. So you are again using the enqueue function. So at this time, let us assume a new node, which is again a temp, has to be created. Let us assume the second node is created at the address, let us say 500. The address here is, the temp address is 500. Are you following my point? So here you have two elements. Let us assume that you want to add 7. This is your enqueuing. Now here, yes. Shall I proceed?
Yes, sir.
Shall I proceed?
Yes, sir.
Now here I am assuming that my temp node address here is 500 now. Now where I have to attach? I have to attach this 500 to 100 arrow P next. Then only I am maintaining a link. That means from here till here. Okay. So I need to remove this cross here. Isn't it? Yes or no? I need to remove this cross, and then I have to keep 500. Here I have to keep, because it is very small, I'm just writing here. When I keep 500, then only I'm maintaining a link, and then I have to keep this fellow as the end of the node or end of the list. So how do I do that? So that means in enqueue, you are saying that temp arrow P next is null, but what extra code needs to be written? Rear arrow P next was earlier null, needs to be changed to temp. And where to write that? Where I have to write that means, so you have cross-checked anyway front. Now also check if rear is not null, because if rear is null, you have to anyway touch temp only. Rear is not null, then you say that rear is equal to, then you say that rear arrow P next is equal to temp. Now concentrate this what I am doing. concentrate this what I'm doing. So initially when node is when queue is empty, let us consider you are enqueuing 4. At the time both rear and front both are null. You are changing front to temp. So front is pointing to 100 and rear is not null is false. So you worry about this code. Now you are saying that 400 arrow x is 4 and 400 arrow p next is null. And now you are saying that rear is also pointing to 100. First node is clear? Is the first node is clear?
Yes, sir.
Okay, now next node.
Yes, sir.
Now the next node. The next node address is 500. Now front is null? No. Front is not null. So therefore you are not changing front. Clear? But now is rear is not equal to null. Is this true? Yes, this is true. Rear is not equal to null is true. So what are you doing? Earlier rear arrow p next. What was that? 100 arrow p next which was null. You are replacing it with a newly created node. What is that? Temp. What is temp? 500. So you kept 500. That means this part is coming. Next what? Temp. What is temp? 500 arrow. So this is temp. This is temp. So 500 arrow. Arrow x is k. What is k? 7. Then what? Then temp arrow p next is null. Why? Because it is a single linked list. Then what? Rear has to point to 500. You should not change front. Front is pointing to 100 only. So now after second node enqueuing, front is pointed here, whereas rear is pointing to 500. Clear? Clear?
Sir, why to keep if condition again at rear, sir?
If I don't keep, then in the first time you will get a problem. Because at that time rear is also null. Null arrow p next. You will get a segmentation fault. If I don't keep if, I'll get a problem in the first node.
Okay, sir.
Okay. Now let us enqueue another node. Now let us say this node has a data element, let us say 100. That means what? I have to create null here. Now let us say this address is 414. This address is 414. Now I need to maintain a link from here to here. Okay, so that means I have to delete, just traverse this code now. Now what is happening? Temp is 414. Now temp is 414 here.
Yes, sir.
Okay. Now front is not null, so therefore there is no question of changing front. Now rear is not null. This is true again. What was rear earlier? 500. Now what is 500 arrow p next? Earlier it was null. This null you are now replacing. This null you are replacing with 414. This null you are replacing with 414. This is what you are doing in if rear is not equal to null. Then what is pending? Then the pending element is in 414 arrow x. You have to keep k, which is nothing but 11. And in 414 arrow p next, you are keeping it as a meaningful significant, meaningful last node by keeping it as a null. And you are moving the rear to this address, which is 414. Now rear is pointing to 414. Is enqueuing process is clear?
Sir.
Yes, sir.
Yes, sir.
Okay. Now let's start dequeuing it. Let us start dequeuing. So what I will do is I will copy this, probably. So I'll copy this part and let me drag aside so that I'll get a space here, and then let me start rewriting by concentrating or by emphasizing only the DQ part. DQ part looks very simple. So what has to be done is you need to cross verify that DQ, when you are DQing, Q must not be empty. Okay, so when you are DQing, so where you have to DQ? DQ at the front side. So you need answer. Answer is nothing but, are you following? If friend is equal to null, if friend is double equal to null, then the Q is empty. Then 0. Or you return the error code. Okay. So if otherwise you will come here. So answer is friend arrow X is your answer. Now you take node star temp. The node that you are supposed to delete is friend. So assume that temp is pointing to friend. Now you move friend to front arrow next. So now you are changing friend and then you delete temp. First take the node that you need to delete. Before that, take the value. First take the value, then take a temporary node, which node you need to delete, then move your front node to the next fellow and delete your temporary node. And finally you return answer. Are you following?
Yes, sir.
Yes, sir.
And finally you return answer. Yeah, somebody's microphone is on. 124 Anush, your microphone is on. Okay. So any doubt? DQing is done.
Sir,
Let us see.
friend is double
Observe
equal
this.
to null.
Yes, 146.
Sir, if friend is double equal to null and double and rear is double equal to null also. Yeah.
Not necessary. Now, if friend is double equal to null, that itself will tell that Q is empty. Why do I need to cross verify rear also? Because in enqueuing, I will change rear only when I am inserting at least one item. So if friend is null, directly I can confirm that Q is empty. Because at any case, friend cannot be null if there is something in the queue. Clear?
Yes, sir.
Clear?
Yes, sir.
Okay. So therefore, now let us apply to this 3 elements queue that I have created. So initially, what will be the answer? Initially, what is friend? Friend is pointing to 100. Friend is pointing to 100. Okay, so friend is pointing to 100 first. So this is where friend is pointing. So initially, friend is pointing to 100 here. So that means 100 arrow X. What is that? 4. I'm taking 4. Where am I taking 4 into answer? Now I'm taking temp. So this is nothing but my temp. What is temp now? Temp is 100. Okay. Now I'm saying that now my friend is not this. My friend is front arrow P next. What is front arrow P next? 500. So I'm saying that now this is my friend. So in this process, am I changing rear? No. So this will be my front now. And then we are deleting this node. We are deleting this node. Clear? Clear?
Yes, sir.
Okay.
Yes, sir.
And finally you need to display. So this is why you don't have any iterative logic here. And in that process, you don't need to shift the elements when you are dequeuing, because you are just cutting it and you are saying that my head is not 100, my head is 500 now. So again, when the user is dequeuing a data element, this 500 also will be cut and the head will be pointed to 414. So at no point, irrespective of the size of the queue, you don't need to maintain the size of the queue at all. So theoretically speaking, your size of the queue is infinite, but practically the size of the queue depends on the availability of heap. Clear? Now coming to the clear. Am I clear? Am I clear?
Yes, sir.
Yes, sir.
Okay, so coming to the display part is very simple. So what has to be done is for node star P, starting from front node till P is not equal to rear node. No, till P is not equal to null, because last rear node also you have to display. You have to move P arrow next, and then you have to display C out P arrow X. Clear? So starting from front node till the end of the list, I'll start displaying the elements, which are nothing but Q. Probably you can keep a symbol something like this, like this. So this is a Q. Somebody please respond. Am I clear?
Yes, sir.
Okay.
Yes, sir.
In the destructor part, I need to delete all the nodes. Whatever nodes are there, I need to simply delete, which is same as deleting a single linked list starting from the head node. Here head is nothing but front. So starting from front till your front is not null, you have to delete front. Simple. So shall we start coding?
Yes, sir.
Yes, sir.
Okay, so did I open the C++ editor? No. Okay, so meanwhile, what I'll do is, so this is where you can also justify the importance of front node star pointer. Okay, maybe what I'll do is, I'm sending a form. I'll open this for 30 seconds. Your chat box. Meanwhile, I make my environment ready for queue. Request all of you to fill up that form. That will be considered as today's attendance. Can somebody acknowledge, is my audio is coming? Am I audible?
Yes, sir.
Did you got the link?
Yes, sir.
Yeah, so start answering the two questions and make ensure that you are writing the last 3 digits of your roll number. Meanwhile, I'll open the C++ online editor. Is it accessible? Somebody come in. Is it accessible?
Yes, sir.
Yes,
Okay.
sir.
Completed. They are very simple.
Yes, sir.
I have given just 2 questions so that it will eases the attendance process of mine instead of cross verifying everybody's number on the chat box. So did everybody has answered?
Yes, sir.
Yeah, I'm just
Yes, sir.
I'm stopping the acceptance of these responses. System got hanged. Now I got 0 responses. Make ensure that you have clicked submit button.
Sir, submit.
Okay, I got 47 responses.
Sir, 180 is having problem with the link.
Who is having the problem?
Roll number 180.
118. No, 180. 180. Can anybody respond? Am I audible?
Sir,
Yes, sir.
Yes, sir.
Okay. Now my system is completely hanged. Let me close some apps because there is a Stack Overflow error in my system, I think. Okay, I closed PDF, sorry, PPT. Let me go to desktop. Anyway, if any student is finding problem in answering that, I think you said 180, right?
Sir, I submitted, sir. It's coming now.
Submitted. Okay, fine. Fine. Okay, please bear with the system delay. Okay, meanwhile the system gets on, some of the other instructions which I said I'll be telling you is, starting from tomorrow you will have second lab internal exam. Are you listening?
sir, tomorrow, sir.
Or else today, starting from after lunch. When do you want me to conduct? Today, tomorrow, or day after tomorrow?
Day after tomorrow, sir.
Okay, I have all
Sir, next week if possible.
next week.
Next week.
If possible, sir.
No. It will be very delayed otherwise because
Sir, online, sir. You told
come
offline.
again.
You told offline, no, sir. Lab internal.
No, it is online only. I'll conduct online, not offline.
Okay.
I'm trying
Sir,
to.
you told after college reopens, no, sir.
Yeah, initially we thought of, but we were told to conduct the assessment of all internal evaluations that includes the lab also through online only. But external examinations will be offline as of now. That also I don't know whether if the college permits, then probably if there are ways of conducting the external examinations also online, that also they will, I mean, through the coordinator or through the head of the department, it will be communicated. But as of now, your internal examinations has to be completed. That include quizzes, assignments, and the lab internal exam. I'm just closing the Chrome and I'm reopening this. It got hanged because okay, where is it? Yeah, now it is okay. Now it has came. Okay, 47 responses. Fine. Let me stop. So there are 13 students who are absent. So tell that I'll be keeping all these students are as absent. Let me check the score. You might have scored well because, yeah, coming to responses, average score 1.2 only. Okay, review answers. No. Back, post to this course. Anyway, so when I go back, let me go through the questions. Okay, 50 responses. So 10 absentees. So the answer is first one is stack is, I think this is somebody's answer. Where are questions? Questions is this. Yeah. So stack is last in first out, whereas queue is first in first out. Second is both stack and queue are implemented to both the stack and queue are implemented to operate in RAM. And implementation with arrays is difficult than implementation of these with linked list. This is where you will understand. Programming wise, linked list is a little tricky, but operational wise, linked list usage is very easy. Okay. Yeah, I think I have started giving the instructions about the lab. You said you want me to conduct from tomorrow onwards, right? No, day after tomorrow, right? If I'm correct.
Yes, sir.
Yeah.
Sir, what is the question?
So the process is something like this. I will be sending the list of roll numbers who has to come online. There will be two time slots. One is from 13 to 16. No, not 13. 3 plus 12. That means 15. Afternoon 3 o'clock or afternoon 2 o'clock. Shall we start at 2:30? We'll start at 2:30. From afternoon
Sir, 3.
3 to 5:30, one batch, and evening 7:30 to or evening 8 to 10, another batch. Sorry, 8 to 11. Okay, is that okay? There will be two batches. Are you listening?
Sir, 8:30 to 11, 8 to 11.
Yeah, 8 to 11. 8 to 9, 1 hour, 9 to 10, 10 to 11. So total 3 hours. Okay? Yes or no? Anybody has any problem? You have to stay at your home. Attend the exam. Simple. Anybody has any problem? We should have dinner. Yeah, you have dinner 7:30, 7:30 to 8. Or you can postpone the dinner at 11. From 11 o'clock you can have. 11 is not okay. 8 to 11 is not okay. Okay, then you tell me when do you want me to conduct? Another time slot within the same day. Morning there are classes. I cannot disturb the classes timetable. 5:30 to 8:30. But already one batch is doing by what time? 2 to 5.
5:30. 2 to 5:30.
2 to 5
2:30 to
you want me to
5:30.
conduct. Okay, fine. 2 to 5 and then 5:30 to 8:30. Fine. Fine. So initially I will send the roll numbers of those students who got less than 50% of marks in the first internal exam. So they will be assessed first. I will prepare the list. I think I have already given I have already sent the snaps of your first internal examination performance on your group. Sometime in this week only. I think sometime back in Monday or Tuesday I have sent. Did you received? Please talk to me.
What, sir? Not understand.
You're not
Yes, sir.
understanding. You know, everybody know what is your first internal theory internal examination marks. You know or you don't?
Yes, sir.
You know, right?
Yes, sir.
So among all these 60 students, I will randomly select 10 students whose performance is less than 50% of marks. And that will be categorized as batch 1. Another left out students will be batch 2. Another left out students will be batch 3. So likewise, I will conduct in 2 to 3 days, starting from day after tomorrow.
Yes, sir.
That will be from 16th onwards. Have you understood? Have you understood?
Yes, sir.
Yes,
Yes,
sir.
sir.
So the assessment will start with Vivavos first. I will take one-on-one Vivavos. I will send the WebEx request to the entire class, but the students whose roll numbers I have indicated has to mandatorily join because they have to respond. Okay. First is Vivavos. What are the topics? What is the portion? Portion will be Unit 3, Unit 4 and Unit 5, which is the portion for your second internal examination. So in these concepts which we have been discussing for the last 15 online classes, you will have online Vivavos first. So after that, I will give 2 programs. One will be from Unit 3 or Unit 4. The other will be Unit 4 or Unit 5. And execution of both the programs are mandatory. It is also one-on-one. Are you following?
Yes, sir.
You have any problems?
When where should we execute and solve?
Yeah, that is a expected question. Okay, so where should we execute? In the same way, like how I am sharing the code editor, which is on the Chrome, you also open on your system and share this with me. I'll keep quiet, you start coding. Notice that you will be sharing the content only to me. So other students will be doing their own programs. But I can see everybody's content. Are you following?
Yes, sir.
Yes, sir.
You have to type on
Use-
screen and it will be visible to me. For example, assume that you are asked to demonstrate virtual base class. Start programming on your system. Share that screen to me. like the way how I am explaining and how we have been discussing, in the same way you also explain it to me. That will be treated as your assessment.
Sir, Qs did not completed, no, sir.
Which are not completed.
Qs logic.
This class you have to complete. Up to today's class you have to complete. Except exception handling, everything else is there in the syllabus. Any other doubts? Now you may say, what is the problem? I'm sorry. For those students who have only mobile phones, because typing will be very difficult for those students who are having only mobile phones. So for those students, you dictate the code when I'm asking. On your behalf, I'll start typing. You tell the code, I'll start typing. On my system, you see the screen.
Sir, we can use online compiler.
Yeah, I'm asking you to use online.
The computer.
Yeah, in the computer. If you have a.
While we are typing, we had to speak or we had to type on typing go on.
Not necessary. You have to. You have to simply share your screen to.
Okay, sir.
Okay.
So, sir, only classwork programs are lab also.
Mostly whatever we have discussed in the class. Programs.
Okay, sir.
Okay.
Okay, sir. Okay.
Any other doubts?
Direct we have to code, sir.
Yeah, direct you have to code. Talk to me and then directly you code. If you need further explanation, you take a whiteboard and then discuss the logic with me and then start coding. Any other doubts? Any other doubts?
Sir, best of exams or average of 2 lab exams?
Average of 2. Average of 2 only.
Sir, in lab we have, for questions we have draw, sir. For here.
We have what?
For questions, sir, draw. Cheats.
Oh, okay, cheats. Here there are no cheats. Here there are no cheats. I will tell a question, you have to execute. Simple. And when some student is answering, the other students are all witnessing. So I can't give explicitly a difficult question to explicit student and explicitly a simplified question to a explicit student again. You're getting my point? Whatever has been discussed in those lines only, concepts will be assessed, whether you are following or not. Notice that I will be asking those questions which are there in your lab index sheet. Maximum. Any other doubts? Yeah, there is a problem from my side because I have to assess for both section A and section C. But section A students, they have asked me to start on day after tomorrow. That will be on Saturday. So on Saturday, I'll take up section A, and for your section, I'll start assessment from Monday onwards. Because the platform is also different, I have to use Microsoft Teams for section A and Cisco WebEx for section C. And for your information, notice that your performance will be recorded officially. It will be recorded. Any other doubts? Now, for those students who are unable to take up the exams because of networking issues, okay, so you can take up by attending the Viva's questions first using ConCall, and also and also participate in the exam by using ConCall. Are you following?
Yes, sir.
Any other doubts? Please respond. Any other doubts?
Sir, from Saturday no, sir, exam. Lab
No,
interview.
from Monday. Monday. For you, it will be from Monday. Somebody said we'll write it on next week, so it has came to next week only. Because Saturday I have already committed for section A. I told them in on Monday only. Is that okay? Because now I cannot ask you to change to Microsoft Teams. And notice that you cannot bluff here, because I'll pinpoint to each one of you, and we have enough time. If there is an issue in terms of timing, you have to stay beyond. Till the point where I am convinced, till the point where you are in a position to execute the programs. Either way. Clear?
Sir.
Portion is 3, 4, 5, including this class. Please talk to me. Any problems? Am I audible?
Sir.
Yes, sir.
Yes, sir.
What happened? Am I audible?
Yes, sir.
Yes, sir.
Okay.
Yes,
Okay.
sir.
Where is 123? Akshaya. Am I audible?
Yes, sir. Yes, sir.
Clear about the process.
Yes, sir. Yes, sir.
Notice that we are testing humans. We are not testing computers. Okay, sure. So start programming now. Somebody please respond.
Yes, sir. Yes, sir.
Okay. So let me take C++. I think I have taken, it's been a lot of time. Already. You have any other classes scheduled today?
No, sir.
Okay, then it is fine. So hash include IOStream and then using namespace std and then what? Then hash define error code. Let us take it as -1. Okay, so let us go to our whiteboard. This is our whiteboard. Yeah, so let us concentrate on enqueuing part, and then let us start writing the queue class with singly linked list. So this is the imp of with singly linked list. Okay, is the code is visible? Is there is no semicolon? Yeah, is this is visible?
Sir.
Type def struct node. Okay, so int x, then node star pointer to next node, class q, let us start writing the private. Let us also start writing the public member functions. Public member functions, I need to write the constructor. I need to write enq a element, and then I need to deq with void. I need to display of void, then the destructor. And in private member function, I need to take node star friend and node star where, these 2 pointers. Next, void main of void. Okay, this fellow requires end. Let us take Q object Q1. Let us take int choice x, return value m. Let us write while 1. Now we will throw the options. 1 for NQ, 2 for DQ, 3 for display, 4 to exit. So then we will say you enter the choice. Enter the choice. So accept C in choice. So this is switch off choice. Case 1, case 2, case 3, case 4, default, cout is invalid choice, and then break. Now case 4, then break. Case 3, you need to have a break. You need to have a break. Case 1, you need to have a break. Okay, so let us start writing the member functions. Are you watching and listening? Yes or no? You? Somebody please respond.
Yes, sir.
Yes, sir.
Default constructor. Now friend is equal to null. Where is equal to null. Then what? In queue needs to return end. You are talking about NQ. Okay. Let us do enqueuing process. In enqueuing process, you need to allocate memory first. So node star temp pointing to null first. Then you say that temp is equal to new node type. After this, if null is equal to temp, this is probably where you got queue overflow. You cannot use the word overflow, so you have to say that queue is full because there is no adequate RAM. Okay, and then you return the error code. So you come here only when the temp is not null. Now, at that case, if front is null, then you have to
Sir, see out.
come again. Yeah, see out.
Line number 37.
Yeah, that is correct. So here front is temp, and we also have discussed that if rare is not equal to null, then rare is equal to rare arrow pointer to next node. Pointer to next node. Otherwise, what friend you have changed, rare you have moved. Then you need to say that temp arrow x is k, and temp arrow pointer to next node is null. Then you need to say that rare is equal to temp. Then you need to say that return 1. Okay, so this completes the enqueuing process. Next, let us complete dequeuing process. So again, int q dequeue of void. Now you need to check if front is double equal to null, then you cannot dequeue. So say that cout queue is empty, dequeuing is not possible. and then you return the error code. Otherwise, you take the answer, that is int answer, which is equal to you are taking front arrow x, then node star temp is following to is pointing to front. Then you move front is equal to front arrow pointer to next node. Then you delete temp, and then you return answer. Dequeuing is done. Next, what? Displaying void queue display of void. Okay, so here if front is equal to null, then you have to say that cout queue is empty. Queue is empty. Semicolon, and then simply return. These two fellows has to be inside. Otherwise for node star p pointing to front until p is not equal to null, p is equal to p arrow pointer to next node. Say that cout p arrow, and this is your link. So I'm just keeping that as a form of a link. Okay, so first is this fellow and then next fellow. Okay, that's it. So display is completed. Next is destructor. So queue build queue of void. So cout, you are in default destructor. Now you need to delete. So what has to be done? Probably you take node star temp initially pointing to null. Now while front is not equal to, okay, so what has to be done? Take temp pointing to front and move front as front arrow p next, and then delete temp. Any doubts? Now let us start case 1. Case 1 is enqueuing process. So ask the user to enter the value of x. So now q1 dot enqueue of x. He has to accept, isn't it? So C in, let us say that as x. Now this value is m. Okay, so if m is equal to error code, then you say that enqueuing error. Else, say that cout it is enqueued. Okay. Next, this is dequeue. In dequeuing, let us assume m is equal to q1 dot dequeue of. Okay, so if m is equal to error code, then there is a dequeue error. Else, cout dequeued item is equal to x. Okay, then displaying cout Elements of the queue are, you write q1 dot display, and this is exit. Here, for the sake of completeness, just before break, you return 1. It is a true process. Here you return 0. So here the flow must not come. Okay? Following? Somebody please speak.
Yes, sir.
Okay, so let us execute this. Okay, so default constructor, it is asking to enqueue, dequeue, display, exit. So let me take one enqueuing. It is enqueue 45. It is enqueued. Let me display. Displaying 45 and then arrow. Let me again enqueue. Let me enqueue 35. Let me again display, which is 3. Move on. 5 and then 35, it has to come, right? So there is some mistake where we have done enqueuing. Let me again display. Let us try to display. There is a problem in front, rear, enqueue. Enqueue, where is enqueue? Enqueue is here. Front is temp, rear is equal to rear arrow p next. Temp arrow p, temp arrow x is k, and then rear is temp. Okay, dequeuing we are not at all doing. Let us go to display, starting from front. Any bug we have done? Yes, is there any bug? Let me rerun this. One is enqueue. Let me enqueue 10. Let us display. Let me enqueue again. Let me enqueue 20. Let me display. That means there is a bug. You are not properly enqueuing. There is a problem in enqueuing. Go through the enqueuing code. Enqueue of X.
Rear arrow p next equal to rear arrow p next equal to temper.
Rear arrow. Yeah. Somewhere we have done mistake. Enqueue temp is you have created. If front is null, then front is temp. If rear is not null, then rear is equal to rear arrow p next. Okay, then what? Rear arrow p next must be equal to temp. That is correct. Rear arrow pointer to next node. Rear arrow pointer to next node must be equal to temp. Rear arrow pointer to next node must be equal to temp. Means only when rear arrow pointer to next node is null, then only you have to do this. Rear arrow pointer to next node, if it is null, then only you have to do this. Every time you have to do this. If you keep it every time, then rear arrow pointer to next node is anyway null, so you are making it as temp. Now temp arrow x is okay, this is temp arrow p next is null. The point is if rear is not null, then you are changing rear. Okay, let us execute this. Okay, enqueue. Let us enqueue 5. Doing process problem. There is a problem here. Just check it out. Where arrow p next is null. Yeah, there is a problem because is temp. That time rare is null arrow. So how can you do null arrow? That means if where arrow pointer to next node is null, only you do this. Execute. NQ5 doing a mistake here. Yes, anybody please come in. What is the problem here? Front is temp. Rare is not equal to null, then rare is equal to rare arrow p next. Rare is equal to rare arrow p next. Are you there? Anybody? Am I audible?
Yes, sir.
Yeah, what is the mistake here?
Sir, double time doing P next, sir, in first case.
Hmm.
Line number 43.
Yeah. Rare is equal to rare arrow p next. Rare is not null, then rare arrow p next is. If rare is not equal to null, if rare is not equal to null, then rare arrow p next is temp. If rare is not equal to null, then rare arrow p next is equal to. Just check it out. I just opened the last class. Now check it out. Is it visible?
Yes, sir.
The code is visible. Okay. So if rare is not equal to null, then rare arrow p next is temp, and temp arrow x is k, arrow p next is null, and finally rare is equal to temp. Just parse first time. First time we took the address as 100. So at that time you are making as 100. You are making front as 100. Now notice that rare is still null. So this 43 will be skipped. So 100 arrow x is set to 4. Then 100 arrow p next is set to null. Now rare will also be 100. Now next time when you are keeping probably 11, then temp is let us say 400. This time front is not null. Now rare is not null. This is true. So now you are saying that rare is equal to rare arrow p next. Rare already is pointing to 100. So 100 arrow p next, you are asking to be stored with the temp. This is where you are maintaining the link. Where you are maintaining the link. So then temp arrow x, which is a new node. So this will be validation of last node, and you are moving rare to temp. Let us execute this. So NQ, let us say 10. You are NQing 10. Let us display. You got display 10. Let us again NQ. Let us NQ 20 now. Let us display. Now you got 10 and 20. Now again you NQ. Let us NQ 30. Now let us display 3. 10, 20, 30. Now let us DQ. That is 3. Is display, right? 2. 2 is DQ. The DQ'd item is 30. Is that correct?
Yes, sir.
No, DQ
Sir,
has
DQ must be 10, sir.
10. So that means there is a problem in DQ side. So DQ answer is front. Front is pointing to front is null. Okay. Answer is front arrow X.
Sir, answer equal to
Yeah, answer equal to front arrow X only, right? Answer is front arrow X only. Yes or no?
yes, sir.
Node star temp is front, then front is equal to front arrow P next. Then delete the temp. Return answer. Let us see. What is the bug here? Display part front. Okay, this is also fine. Anyway, execute this. I'll save display and display. Now when I DQ, I have to get 5. I'm getting 10. How? There is a problem in NQ. NQ, am I changing rare? Rare is temp is front here.
Sir, now once click display, sir. I think you're
Where in display part?
no, sir. I think in DQ, sir, case 2. I think you're doing wrong element, sir. There,
Which one?
you're printing wrong element. I think, sir, in DQing part.
In DQing part, we are not printing anything, right? We are just returning. We are returning front arrow answer.
In switch case, I think.
Oh, okay. In switch case, what am I printing? I am printing X. Oh, right. I have to print M. Yeah, that is correct. I have to print the return value, right? I have to print M. Under the switch case in DQ part, I have to print here M. Now I think it will come. NQ5, NQ6, NQ7, display 5, 6, 7. I have to get 5 now. So DQ, I get 5. Again, if I display 6, 7 has to come. 6, 7. Again, when I DQ, I'll get 6. If I display, I'll get 7. Again, when I DQ, I'll get 7. If I display, I'll get 8. Again, if I DQ, Q is empty. Q error, DQ error. Display, Q is empty. Again, let me NQ 1, let me NQ 2, let me NQ 3, let me NQ 4, let me NQ 5. If I display 3, I'll get 1, 2, 3, 4, 5. Again, when I DQ, I'll get 1. Again, if I display, so this is correct. Okay? So let me
Yes, sir.
4, which is exit. Prepare well for the exams and then default destructor. So let me stop here. So with this, we are done with the queues, and one more part is pending, which is queue with the templates. I think that you can handle, which is the same as the way we have handled for stacks. You need to attach the STL. Okay, so I advise all the students to also complete the lab exercise, which is on par with the syllabus which we have completed as on today. So complete the execution, and once your execution is completed, once you have understood the logics, then you directly write in the records. That is on the one side of A4 size A4 sheets, and also prepare well for your exams, which will commence from Monday afternoon. The schedule of roll numbers from Monday, along with the time I will send it to you. If anybody has any problems in terms of connectivity issues, get back to me over phone. Okay. So any other specific issues or any other problems? One more thing is I need to conduct quiz 3. When do you want me to conduct quiz 3? Maybe I can take a regular class which is scheduled
Saturday.
not this Saturday. I'll conduct on 21st, Thursday, only 1 week. Syllabus will be starting after the quiz 2 till the concepts that we will complete till 20th class. That means till the Saturday, including exceptions. We are left out with only one small topic, which is called exception handling. Okay, so probably in our daily classes also, I'll turn those classes into assessment classes. Okay, please come in. Are you following?
To update the record for the internal too.
Come again.
Internal exam. Lab internal exam, you have to update the record.
No. Record you write at your own.
Okay, sir.
At your own.
We had to.
Okay, only when you have executed, only you write it in the record. But as on date, you are expected to complete all these programs.
Okay, sir.
That includes singly
In lab
linked
record
list.
also. Sir, in lab record also, 3rd, 4th, 5th unit programs only, no, sir. After 32.
No. Lab has to be lab record with unit 1 to unit 5.
Sir, internal exam. For lab internal exam, sir.
For lab internal exam, I cannot cross verify. Right?
Okay, sir. We had to. Okay, sir.
Okay, so that is why I am saying lab record. Sorry, what is it? Lab record you update from your side, and your lab record marks will be considered only when you come to the college.
Okay, sir. Okay, sir.
Okay. Any other? So quiz 3 is on 21st. Second lab internal exam will be on 18th. Commences from 18th. Okay.
Sir, for lab internal, lab index programs are the programs which we discussed in a class, regular class.
Both. Anything. Lab internal, lab indexed programs, as well as the concepts which are pertaining are the programs that what we have discussed in the class. Those only were asked in the lab index programs also. Okay, did I answer your question? Both. The answer is both. Did I answer your question? Yes or no? Is there any problem? Is there any problem? Let me be specific. It can be anything. It can be anything. See, I can ask you to write a program to convert the number from decimal to octal using stack operations using a ADT class. Okay. So it varies from time to time. But within the syllabus,